Good morning, Bradford Brainiacs. It's Wednesday morning. This is April 22nd. Man, it's so exciting. We have completed one full week of distance learning. So I know, and I'm just so proud of you. I know you're excited about today, and I'm just so proud of you for what you have been able to do. Keep at it. Keep at it. All right, so let's get started with the pledge. I am smart. I am gifted. I am a learner. I am a scholar. I am preparing now for my future. I am the main ingredient in my success. Every lesson won't be easy. Every concept won't be learned the first time. I may get frustrated, but I won't give up and I won't quit. I will try. I will strive. I will thrive. I will achieve. I will succeed. For I am an example of excellence. Clap one time. All right, let's jump on in it. Let's start by reviewing just a couple of things. I want to thank those, first of all, that came on and did virtual office hours with me. Again, you can come on. The link will post at 10:50. It posts in your Google Classroom. And in fact, I might include it in this link because this assignment posts at 10. And we are using Zoom to do our virtual classroom. Again, it's not mandatory. It's just a check-in in case you need help with any of the assignments, all right? We are still in our volume, still doing volume. So let's just, let's go to work. Let's review last week. So last week, we had, an assignment. And the assignment was this. It said assignment for Monday, April 20th. Your assignment for today says assignment for Wednesday, April 22nd. Again, remember, you go to this area right here, the Zoom, to zoom in and make it a little bit larger. All right. And so we were dealing with what? Using cubes and using volume to identify the number of cubes that would be in a box. So we looked at box A. It says Steve fills box A and box B with 1 centimeter cubes. So we went to box A and realized that it was width of 3, length of 2, height of 5. So 3 times 2 times 5 is 30. So you should have gotten 30 cubic centimeters for number 1. You could explain that by multiplying volume is equal to length times width times height equal to 2 times 3 times 6. Oh, sorry, times 5 equals to 30 cubic centimeters. All right. The next one asks you, how many cubes can Steve fit into box B? Box B, you have 6 times 2 times 2, which gives you 24 cubic centimeters. Then it says show your calculation. So you do the same thing. Volume is equal to what? Length times width times height, which is equal to 2 times 2 times 6, which is equal to 24 cubic centimeters. All right, very good. I know y'all got that. Again, we got to delete it so it doesn't So we had 24 for B, and A was 30. Remember that. A was 30, B was 24. We're probably going to need that for the next one. So we go to the next slide. Next slide says, which of the two boxes held more cubes? Do you remember? A held how many? Because we said 1 centimeter cubed is equal to 1 cube. So box A held 30. Box B held 24. All right. So then it says, here's another box. How many centimeter cubes can this box hold? All right. Well, we have 2 times 6 times 3 because we have a height of 2, a width of 6, a length of 3. So that's 3 times 6 is 18 times 2 is what? 36. Good job. So this can hold 36 cubic centimeters. All right. Now, number 5. Remember, we scratched this out. We came down here. If you had to design another box with the same volume as number 4, the volume for number 4 is 36. What would the dimensions be? So what can we do? Let's see. We can change it. So our volume must be 36. So let's say we did 3 centimeters by 3 centimeters by 4 centimeters. Let's see, that would be 3 times 3 is 9 times 4 is 36. That would work. Man, what else could you do? You could do 1 centimeter times 2 centimeters times 18 centimeters. That would be a narrow box, huh? That'd be almost like be a very narrow, like a tower. You could do you could do 2 times 2 times 9. We did that already. You could do, oh no, you could do 2 times 2 times 9. You could do 9 centimeters, then 2 centimeters, then 2 centimeters. That will give you 36. So the possibilities are endless. Well, they're not endless, but you can vary them. And so the idea is choosing different numbers, different dimensions that add up to the same volume. And again, remember, you use your volume formula, which will be length times width times height. Y'all have done a great job. I know you did. I know you did a great job. I know you got all these correct. I can't wait to review them. I'm really proud of you. All right, so today we are going to explore, we're going to push it. We're going to push it just a little bit. And so this is week 2. So we talked about volume, and we said the volume can be measured in cubic units. And typically for our units, we've been using centimeter cubes. So volume can be measured in centimeter cubes. Capacity can be measured in milliliters. So capacity, sometimes called liquid volume, can be measured in milliliters. In fact, if you've ever had a water bottle, you know that a water bottle measures the amount of the water bottles in milliliters. That's capacity. That's capacity. So you can do that in milliliters. So in this water bottle, if you look at this water bottle, hold on, what you see is, do you see it? There you go. Hold on. My light is kind of conflicting with it. But it's, you see 500 milliliters. So that denotes capacity. Capacity. All right. So we are going to look at capacity and the relationship between volume and capacity. That's what we're doing today. We're looking at volume and capacity. All right. So let's see if we can play with it a little bit more. So we're going to explore the relationship between volume and capacity. Then we're going to compare amounts and of rice and milk. We're not going to do that. But what we're going to do is we're going to look at how you can guess. So how many of you have ever played the game where they put candy in a box or in a jar and they try to tell you to estimate the number, or maybe they put marbles in, estimate the number of items in a jar? Okay, well, you're going to see a video like that. We're going to watch that video. That's one of the links. It's a video to tell you how to do it. But we're also going to look at the comparison of cubic centimeters and milliliters. The relationship between cubic centimeters and milliliters. And we're going to do a chart. So I hope you have your notebooks, because you're going to have to write this chart in your notebooks. Are you ready? All right. So let's go. So we know that when we did volume using cubes. And what we did was, based on the size of the box, we multiplied the length times the width times the height, and that gave us the volume. And we said that volume is equal to cubic centimeters. So maybe you don't remember, but let me see if I can remind you real fast of what we said. We said, let's go look at it. Let's go ahead and pull up our whiteboard. We said, okay, we said that volume is equal to length times width times height, which then equals centimeters cubed. And we said that 1 centimeter cubed is equal to 1 cube. Right? So when we wanted to know the number of cubes that could fit in a box, we would simply find the volume, and whatever that answer was in cubic centimeters, it would also be equal to that in cubes, in little cubes, right? The same thing applies for capacity. So when we figure out the capacity of something in cubic centimeters, that same number, cubic centimeters, is equal to its capacity in milliliters. All right, so if we were to build a chart, let me show you what the chart would look like. So the chart would look like this. In box 1, you'd have the length, the width, the height, the volume, the number of cubes packed, and the liquid it can hold, which is volume in milliliters, or liquid volume. And they would be so similar, right? So when you think about the volume, let's draw the chart. let's draw the chart. All right. Whiteboards out or notebooks out. So we have box, which is just our number. We have the length, the width, the height, well, let's erase that, make that height better. Height. Then we have volume. Then we have number of cubes. And finally, we're going to have, what's going to be the last thing we have? We're going to have liquid volume, which is measured in milliliters. That's called what? It's a C word, capacity. Capacity. All right, so box one, let's look at the example they gave. The example they gave, let's go back to it. 10 by 12 by 9. All right, 10 by 12 by 9. So you have 10 centimeters, 12 centimeters, 9 centimeters. All right, so what's the first thing you need to do? You need to find the volume. So how do you find the volume? Volume is equal to length times width times height. So the first thing you need to do is you need to multiply 10 times 12 times 9. 10 times 12 is what? 120. All right, 120 times 9. This is a lot harder than it looks. Is equal to 0, 8, 1. All right, so you have 1080 centimeters cubed. All right, so if you were to estimate based off that number, about how many cubes would you think would be in it? It would be the same number, right? So about 1080 cubes. And then what would the milliliters be? Same number, 1080 milliliters. It's just that simple. Man, it's not difficult at all. It's not difficult at all. It's amazing how not difficult that is. You just have to remember that volume is equal to capacity. So if volume is centimeters cubed, it is equal to the capacity of milliliters. All right. So let's do another one. Let's do another one. Let's see. Let's make some big numbers. Y'all want to make some big numbers? Let's make some big numbers. Yeah, all right. Let's make some big numbers. All right, so let's say we did 2, 4, 6, 8. 8 by it's not gonna let me do that. All right. Well, let's change it because it's not gonna let me do that. Width is 8. Depth is 10. height is 15. All right, so let's see. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we do 8 by 8 by 10. And let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So we have a height of 12. We have a width of 8 and a length of 10. Uh-oh. Let's go back to our whiteboard. Where's our whiteboard? Hold on. All right, so we have this is number 2. We have a length of 10. We have a width of 8. We have a height of 12. All right, so volume becomes what? Length times width times height. So length times width is 80 times 12. 80 times 12. 80. 80 times 12. 80 times 12 is 960 centimeters cubed. All right. So we said that volume is going to be equal to the number of cubes, roughly. So how many cubes can fit in that box? 960. All right. And we also said that volume is equal to capacity. So what will be the milliliters? It will be the same, 960. All right. Let's try one more. Let's do one more. I'm gonna let you do this one yourself. All right. I'm gonna just build it. So you ready? Let's go and build it. All right, let's build it. All right, so we have a width of, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Width of 13. Width of 13. So we have a width of 13. All right. What about a length? You ready? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Woo-wee! So we have a length of 15. a length of 15. All right, now we got to do height. Y'all ready to do height? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. Woo! So we have a height of 20. All right, so I'm gonna give you a chance to fill in the rest of the chart. I need the volume, I need the number of cubes, and I need the capacity. Volume, number of cubes, and capacity. I'm gonna give you 1 minute. I'm setting my timer. Setting my timer. All right. All right. So we know that volume is equal to length times width times height. Length times width times height. All right, so length times width is 13 times 15. Now, I know that some of you did it using standard algorithm. Some of you did it using box method. Some of you used a calculator. But you know that if you did it either way, you would end up with the number 195. And then you multiply that times the height, and that would give you 3,900 centimeters cubed. All right, which means how many cubes is it? Can fill that box? 3,900. And how many milliliters make up the capacity? 3,900. Man, y'all are so awesome. Y'all are so awesome. So again, that's what we do. And that's what your homework is going to be for tonight. So I haven't finished setting up today's assignments, but what I want you to do is I want you to make sure I'm sharing the right thing. I am now sharing my classroom. So for tomorrow, I haven't finished yet, but let me show you what it looks like so far. There's a video I want you to watch called Candy Volume. That one didn't work. You're going to watch Candy Volume, and then you're going to complete. In fact, I'm going to go ahead and add the assignment now from my Google Drive. It is called Day 3 Assignment. And I'm going to rename it. Well, let's look at it first. You ready? I'm going to call it Assignment for Wednesday, April 22nd. All right. Now, I'm going to blow it up just a little bit. All right. So it asks you for each situation to draw a sketch, then calculate the volume. Of course, you can't draw a sketch, so you're going to just have to calculate the volume using the information given. A small fish tank is filled to the top with water. The tank measures 15 by 10 by 10. What's the volume in cubic centimeters? And then what's the volume in milliliters? Then you have another one. Pencil box with 30 centimeters cubed. What might the dimensions of the pencil box be? All right, 30 centimeters cubed. What might the dimensions of the pencil box be? What's the volume? Okay. Then this one, you're finding the volume of the prism, and then you're changing that volume into milliliters. You're just gonna mark off what it would be in milliliters. In fact, you really just, yeah, will be the closest in milliliters. It's not a difficult assignment. All right. Um, that's kind of a well, I guess I could give you a preview into the next assignment because that might be a little bit more of a push for you. All right. So what we're gonna do from there is we're gonna do this. See, volume like area is additive. And the volume of a three-dimensional object can be calculated by decomposing it into smaller objects and calculating their volumes and adding those together to determine the original object's volume. So in other words, when you have a shape that's not just a singular rectangular prism, it's really probably the mixture of multiple prisms. And so you have to take those multiple prisms apart in order to figure out the volume of the total thing. Let's see if I can show you an example. Okay, they don't give one here. So let's build one. Y'all want to build one? I think you do. I think you do. So in order to build one, we're going to go back to that activity we did. No, we're not. We're going to switch. All right. So let's build one and let's talk about it. So we're going to build one that's here. Let's see. And maybe I'm pushing you too fast. Okay. Oh no. Uh-uh. All right. So no. All right. So if you were to look at this, guess what you would see? You could see two different sets of prisms. You could see that you have two layers that are one by, I mean, one, two, three, three by one, two, three, four, five, and then 2. So you could actually break this down 2 ways. You could break this down 3 by 3 by 2 plus 2 by 3 by 4. That might not have made sense. Let me see if I can try to make it make sense. You have this you could see here, and maybe what would be easier is if I change the color of some of the blocks, right? So if I kept all the first layer blocks the same color, and then so here you have 2 layers. So let's say I change these blocks to blue, and I built this second 1, 2. Right? So now you could see the two dimensions, or the 2 separate prisms I was talking about. This first prism can be measured 3 by 5 by 2. This second prism is 3 by 2 by 2. All right, so we have 3 by 5 by 2 and 3 by 2 by 2. All right, so let's figure out the total volume. You ready? So you have prism 1, length, width, height, volume. You have prism 1 that's 5 by 3 by 2, which gives you a volume of 30 centimeters cubed. Then you have the second one, which is prism 2, which is, what was it? 2 by 3 by 2. All right, which is 2 times 3 is 6 times 2 is 12 centimeters cubed. All right, so to find the total volume, you simply add them together, which gives you what? 42 centimeters cubed. All right, now how many cubes do you think make up that total volume? 42. And what will be the capacity in milliliters? 42 milliliters. All right, man, y'all are doing good. Y'all are doing good. Want to try another one? Let's try one more. All right, let's say we took this same prism and added the same figure and added some more. No, let's not do that. My color's off too. Hold on. Let me see if I can match that color better. Yeah, there we go. That's still off, huh? Yeah. Yeah, okay. All right. So now, based on this, hold on. Let's see if we can. What's the blue that we chose? Is that the blue? All right. So based on this figure, let's see if we can figure out the two prisms. You see two prisms, right? You should be able to see them because of the color difference. All right. So what is the measurement? What are the dimensions of the blue prism? We'll call this prism 1. 3 by 3 by 3. Write that down. So prism 1, length, width, height, volume is 3, 3, 3. All right, let's see prism 2. Prism 2 is a length of 1, 2, 3, 4, 5, 6, 7. Length of 7, width of 3, height of 2. Length of 7, length of 7, width of 3, height of 2. All right. So now I want you to take 2 minutes and give me the volume of the two prisms separately and then the total figure together. I am setting my timer. 2 minutes. I know some of y'all probably did it in your head. It's not even bothering you at all. But some of us had to work at it, do a little bit of math. But it's all good. However you get it, get it. That's all I'm saying. You got about 25 seconds. I know you got it. All right. So let's do it. So 3 times 3 times 3 gives you what? 27. Ooh, I don't like the way that looks. 27 centimeters cubed. All right. 7 times 3 times 2. 7 times 3 times 2, 42. Gives you a total volume of 69 centimeters cubed. All right, how many cubes do you think is there? How about 69? What's going to be your capacity? 69 milliliters. So, man, this is great because this is going to be the second part of your assignment. You ready? See if I can. All right, so the second part of your assignment is going to come from this. It's called Prisms Together. And you're just going to have to do this page right here. You're not going to have to do the sketching, but you're going to have to look at Prism 1, Prism 2, decide how you're going to break it up, and then do the volume of it, of the whole shape. In fact, you'll just do these two. And again, you can break it up in multiple ways. You can break up the front from the back, or you can break up the bottom from the top. So if this is 4 total, then this is 2, and that means this is 2. Yeah, don't let it frustrate you, but you're going to have this to do as the second slide of your homework for today. All right? You've been very good. I'm so excited. Just want to remind you of a couple things. All right? We learned a lot today. We learned a lot. We learned that volume is equal to length times width times height. We learned that this same volume, centimeters cubed, is also equal to 1 cube. Then we learned that volume is equal to capacity. That means that 1 centimeter cubed is equal to 1 milliliter. Then we learned something else. We learned that you can decompose prisms to find volume. All right. So again, watch this. If you have any questions, I'll be on at 11 o'clock to kind of walk with you through some stuff if you need it. But again, I'm proud of you for the day, and I can't wait to see you on Monday. We're going to go a little bit further on Monday. All right? Man, y'all have an amazing day. I will talk to you later. So make sure you do these assignments. They are due by Friday at 5 p.m. Friday at 5 p.m. Have a great day.